What is an LLM? Let's establish a working definition. A large language model is a probabilistic system that interprets intent, generates structured output, orchestrates tool invocation to complete tasks. Here's what matters. LLMs are not a replacement for engineering discipline. They are a force multiplier embedded within the established process to invoke on demand through APIs, agents, or function calls. Think of them like your databases, matrix queues, or CI/CD pipeline, critical infrastructure that amplifies capability when properly integrated. When organizations ask how to operations LMs into their stack, I focus on four foundational architectural decisions. Deployment topology, cloud, on-premise, edge, each has a different latency and cost. Knowledge grounded, how the model access and reasons over enterprise data. Capability boundary, what tools a LM can invoke, what permission it has, and where are going to be the humans in the loop are going to be required. Governance posture, evaluation frameworks, version control, rollback procedures, compliance checkpoints. Just like any production system, if these aren't resolved early, AI adoption becomes a cost center with unpredictable behavior. Once the architectural foundations are in place, LLMs get embedded strategically across the delivery lifecycle, products and requirements, development, testing, security, operations, governance. The real value isn't automation for its own sake. It's faster convergence to quality outcomes while preserving accountability. This is where LLM fundamentally reshape how we estimate software delivery costs. You still begin with a traditional parametric model, scope, complexity, team velocity, and risk budget. But LLMs alter the economics. They compress effort in code generation, testing, and documentation phases. They shift costs towards orchestration, prompt engineering, evaluation pipelines, and governance tooling. They move risk forward in the life cycle, expose ambiguity early, but require new competencies in model selection and output validation. If your estimation frameworks haven't evolved to account for this, your budgets and your timelines will be strategically wrong. You're estimating for a workflow that no longer exists. And if you need help in that area, I can help you. The most sophisticated organizations are building platforms where AI is operational and connected. Andro latency is an AI-driven command and control fabric that fuses data from heterogeneous sensors and autonomous systems in real time. Palantir's AIP, integrated with Foundry and Apollo, embeds LLM directly into their operational workflows, enabling decision makers to interact with live data through natural language while maintaining full provenance and audibility. These aren't demos, they're production systems treating LLMs as an infrastructure. The teams building the next generation of technology understand this. LLMs aren't magic. They're engineering components in a larger sense, and they must be designed, deployed, and governed accordingly.